If we have an integral like this, then we can write down the answer. If we remember that idea for this inverse integral, which is the log, I can bring the 5 outside already, which leaves 1 over 2x plus 1, and that's what my u is going to be. If I differentiate that, I get the 2, so that's what comes out as well. So I'm left with 5 over 2 log 2x plus 1. Did you get that? What about the next one? True, let's think about, we've got 2 of these things though, so what about the next one? 4 over 1, or just 4 log x minus 2 plus c. What goes here? In the middle? Minus, right, because we're subtracting. So if I have 2 terms to integrate, remember when we integrate, just like differentiate, we just integrate each one separately. I can write down the answer to that integral. What we do if we got plus c on both, so if I had a plus c for this and a plus c for this, what I effectively do, like any person with money, is I just consolidate my 2 c's into one big C and call it one big C at the end. Okay, you consolidate all your c's into one big one at the end. Don't worry about doing it after each one. Yeah, but there's no guarantee that those c's would be the same. So in fact, I'd have to call one C and one K maybe, and so then I'm going to say, okay, let's call C and K something else. In other words, we're only interested in the fact that there is a constant. Yeah, just an unknown. Yeah. Yeah. So, these 2 fractions, what I want to talk about today is actually simplifying a more complex fraction that we're going to look at in a second into 2 simple fractions like this. And it's handy to be able to do that, because then we can integrate it, that we can just literally write down the answer. So let's look at these 2 fractions again. 5 over 2x plus 1 minus 4 over x minus 2. What I want to do is add those fractions. Well, take them away actually, but the rule is the same. So if I want to combine 2 fractions together, add them together, or subtract 2 fractions, I remember that to add or subtract fractions, the denominators must be the same. Remember, if I have something like 2/3 plus 1/4, what would I have to do to add them together? What would you do if I said to you, add those 2 fractions together? To be able to add them, we need the common denominator. Now, look at this. How do I get the common denominator? I times that by 4. I times that by 3. So if I times the bottom by the other one, I'll end up with 12ths. And I end up with something over 12 plus something over 12. But I can't just decide I'm going to times this by 4, can I? And times that by 3. If I'm going to times that by 4, what must I do as well? Times the top by 4, okay? I've got to times that by 4 as well, and that by 3. 2 4s are 8. 3 1s are 3. What's the answer? Record this. We're going to add or subtract. We can only add or subtract things that are the same. So we make the thing that we're adding the same. We don't add them when we then come to the final calculation. 8/12 plus 3/12 is 11. 11 what? 11 twelfths. Stupid. Okay? Not 11 24ths. Right. I want to add, well, effectively actually subtract, but I want to combine these two fractions. I can't do it. Why not? What's not the same? And the denominator's not the same. It's not common. How can I make them the same? Right, multiply by the other. Exactly right. I take the first one and I multiply it by the second one. And I take the second one and multiply that by the first one. I don't need to write them the other way. Exactly, I must do the top as well. So I take whatever the numerator is and multiply that by the top, the other one, x minus 2. Yep. Now, there's something I can do now because I've got a common denominator. What can I do now? Think of what we did with the numbers. What's my next step? Add what together? Right. 5x minus 2 minus 4, 2x plus 1. And what goes underneath? Nothing? Why? Did I do that here? 12 plus 12 is 24. To be able to add the numerators, what must be true? These must be the same. How can I add these, or subtract in this case? Because the numerators are the same. So what goes underneath? Exactly, just one lot of that. In other words, however you decide to write it down, one lot of those, the common denominator. That's a minus there, isn't it? What can I do with the numerator now? Can I do anything with it? Gather like terms, exactly right, Luke. Expand out the brackets and gather like terms. So I'll just pause while you do that and then write down that simplified form of in the numerator. So hopefully if you expand out the brackets, you get something like this on the top, and then you combine the terms, collect together like terms, and you end up with this as the numerator. So this could be our fraction. Just multiply out these bottom two brackets for me, and see what you collect like terms there as well. And what does that end up giving us? You get that? Not 4, 2. Some idiot decided they were going to tell me the wrong answer there. I didn't name you, Tony, but you are the idiot on this video. Okay. Let's look back. I took this fraction, these two fractions, and I wanted to add them together or subtract them. The method is exactly the same. So what I did was I chose the common denominator, then multiply together the two terms in the denominator and multiplying the top by them the same for reasons outlined here. And I end up with this. Now imagine if I'd been asked to integrate minus 3x minus 14 over 2x squared minus 3x minus 2 with respect to x. if I could write this integral like this, it's trivial. We've just done it. There it is. I can write down the answer. So what I need to do is to be able to write that like this, and then I can do it. And this afternoon we're going to be starting to look at Laplace transforms, which is a way of rewriting components in an electronic circuit in such a way that they end up being algebraic expressions which may look something a little bit like this. And then what we do is we use these ideas of rewriting it like this to then do the integral effectively. A very useful technique to be able to rewrite something like this as two separate fractions, and the method to do this is called the method of partial fractions. And that's what we're going to look at.